So we have a rotating bar which is made of steel, and that steel grade is given that is 45 C8, and the ultimate tensile strength is given as 630 Newton per mm square, and it is subject to an completely reverse bending stress. And the endurance limit of the steel is also given as 315 Newton per mm square. We have to determine the fatigue strength of the bar for a life of 90,000 cycle. So this is a question of finite life example. Okay, this is a question of finite life subject to I mean completely reverse bending stress. So this type of problem can be only cannot be solved by numerical method or equation. These are solved by graphical method. Okay, so let's look how to solve this problem by graphical means. Okay, so this is a question when the component or material is designed for finite life, and this plot I am explaining can be used only for steel material having finite life, right? In this question we know it is having a finite life of n 90,000 cycle. This graph and weight plot can only be used for steel. So you can see we will be using SN curve for solving this problem, and both x-axis and y-axis will the in form of logarithmic function. Okay, it will be log value, log n versus log s, or strength, fatigue strength, it will be tensile strength. So the x-axis log n, y-axis log s. So the first step to solve this type of problem, we have to locate point A and B. So this problem I already mentioned can be only solved by graphical means. So very first thing we have to do is to locate the point A and point B. So I've shown you the coordinates to just draw point A and point B. Point A, the coordinate will be, in the case of steel, for having finite well, this fixed value you have to use to solve this problem. This value cannot change. So the point A coordinate is 3, it will be on the x-axis and log 10 to 0.9 SUT. Okay. On the other hand, point B will be 6 log 10 SC. Okay, that x-axis will not be having any compromise. That value will be fixed. Only thing we have to find is the y coordinate. Why? Because we have the ultimate stress and endurance strength in the question. Just simply we have to substitute that value to find the y coordinate of both A and B. And then you can find locate the point A and B. That's the first step to solve this type of problem. So uh, same way we can find point A. So not to find point B, you have to find the y coordinate of point A, which is 0.9 SUT. The ultimate tensile strength is already given, so we have to just substitute and find the value of log 10.9 SUT. Similarly, you can find the y coordinate for B, that is log 10 SC. So now we got both the y coordinates of A and B. So we got point A and B. Okay, so we'll draw the x-axis and y-axis to then locate the point A and B. Now we got the two coordinates for both A and B. Now just join the line AB. We have 2 points A and B, right? Just join the line AB. And just draw the from B, just draw horizontal and vertical from point B. Next step is we have to draw a vertical line from the number of cycle part. You know, in this question we are given 90,000 cycle. That's the number of cycle. So we have to determine log 10 raised to n, because in the x-axis it is log 10 n. That's in x-axis. We already have the value of n, which is 90,000. So log 10 uh, 90,000, you get the value of 4495 in the x-axis, because that's the x-axis corresponds to number of cycles. From that point 4.945, approximately you have to draw a vertical line upward, and that vertical line would intersect AB, or the line we already drawn AB. Okay, we will intersect in some point AB. From that point AB, you have to draw towards the y-axis, and that is what you have to determine the fatigue strength. So this is a simple problem. Just follow this step. Okay, to find the solution. So I already marked the point log 10 S, which is the point we have to determine. So I already told we have drawn a vertical line from the x-axis by log 10 to 90,000. That will intersect at some point at AB. From that point AB, have drawn a horizontal line towards the y-axis, which will intersect at log 10 SF. You need to find the value of SF. That is asked in the question. That is the fatigue strength. Okay, so that Since we are following by graphical method, find a middle point, it can be only solved by method of interpolation. So let's look how to solve by method of interpolation. So this is a method to find by interpolation by the formula y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, since we are concentrating on y-axis because the value which I have to find is on the y-axis, so we are using y. Okay, in this question, always the term which has to be find will be either x or y, where y1, y2, x1, x2 will be the non-point, and one of the variable among x and y will be not. So here you need to find the value of y. Okay, we need to find the value of y because that's the thing we have to find, and we already know y as log 10 s of dash, right? Not we cannot write as s of because this both x-axis and y-axis are in the form of logarithm function. Okay, the s and curve of logarithm function. So I can only write it as log 10 raised to log 10 to s of dash. Okay, that's what we're calling. Then I know the value of y1. y1 will be 2.75. The upper point will be taken as y1 and lower point must be taken as y2. And we know the value of x because the corresponding point to we determine will be 4.9, which you already find from the formula log 10 90,000, right? Log 10 to of 90,000. So we know the value of x. We have x1, we have x2, we have y1, y2. All you have to do is find the value y. So by solving, you get the log 10 s sub dash. From that, a sub dash or fatigue strength can be found. So this is the way to solve this type of problem of finite number of life in the case of steel. I'm repeating that this type of problem can only apply for steel having finite life, and you have to just follow this step to solve this problem. Okay.